Back in November 2025, I showcased my prototype for GateLab, a device for learning how the basic logic gates work, which are fundamental to digital electronics, making possible computers, mobile phones, game consoles, and many other devices. Since then, I've designed a GateLab PCB, the first time I've done a PCB layout, which was very much a learning process. Additionally, I entered GateLab into PCBWay's 8th project design contest. You can find the link in the video description. PCBWay has not sponsored me, but as with any PCBWay community project, the creator receives a 10% commission on each order. Just for entering the competition, you get a Raspberry Pi Pico 2, although you have to pay for shipping, but I plan to have GateLab PCBs made by PCBWay anyway, having used PCBWay before when I had some community designed PCBs manufactured. When I receive the GateLab PCBs, I will do another video on them and highlight any errors if any. Although I was very thorough in working on the PCB layout, until I receive the PCBs, I won't know for sure if there are any unforeseen problems. This video isn't intended to be a PCB layout course, instead I will go over the basics and any oversights. However, in the video description, I will include a couple of links to videos covering PCB design. Let's go over the design process so far. I started with the schematic, which I designed in KiCad. I then breadboard the design to ensure it worked. Next, I made the prototype on perfboard, which you saw in the previous video. I made changes to the schematic, which I'll explain later. In KiCad, I set the footprints for each component to use. I generated the bill of materials, or BOM for short. I used KiCad to make the PCB layout and checked with the design rules checker, or DRC for short. In KiCad, I generated the necessary files for PCB production. These are uploaded to have the PCBs manufactured. While doing the PCB design, I added two main improvements to the schematic, which became revision 1.1. Resistors R22 and R21 have been added, connecting USB-C pins CC1 and CC2 respectively. This meets the USB-C compliance so that all USB-C power supplies work with GateLab. I added alternative power pin connectors J2 and J3, bypassing the need to use a USB-C surface mount connector, allowing for pin headers or a USB breakout board to be used instead. When making the PCB layout, you have to place each component and connect them up with traces, also known as tracks, using the connections made in the schematic. Initially, I roughly placed the components, with the most critical placements being the gate switches and LEDs, so that they were spaced well and lined up appropriately. Notice that the USB-C connector sticks out from the PCB edge. This helps with strain relief when placing an enclosure. Because GateLab isn't a high-speed design and doesn't use lots of power, the trace length or thickness isn't too important. I only had to meet PCBWay's minimum requirements, which I checked using their DRC settings. However, it's good practice to keep traces as short and direct as possible. I originally started with a single-sided design, traces on the top side only. However, because of the large number of connections, I switched to a double-sided design, traces on both sides. I also added ground and 5V planes, PCB top and bottom respectively. These large copper areas eliminate the need in having individual traces to every component that needs to be connected to ground and 5V. It can be tricky to ensure that there is enough space that the traces don't get in the way of the planes. PCBWay dramatically increases the cost of having the PCB made if it exceeds 100mm in either direction, so I reduced the PCB design to 100 by 100mm. This is why planning is so important, and in future I will check the costs before designing a PCB. Note that there was no difference in cost of a single-sided versus a double-sided one if the board is within 100 by 100mm. As always, I value your comments and suggestions. Please see the video description for a link to my site, which has much more detail about how GateLab works. Thanks for watching, bye for now, bye.